this video, we're going to be taking a look at negative exponents and the zero exponent rule or the zero power rule. So before we get into the video, I'd like to just say a few things about the introduction to exponents video. I just wanted to add on to that because I wanted to say, why do we need or why do we use exponents? So exponents are like an abbreviation for repeated multiplication. So for example, on a sort of multiplication test, for example, you have this much of space on the paper and your teacher gives you a question. See, if you get something like this, it's okay because you could do 3 by 3 by 3, the base times itself 3 times. But what if you get something like this? 7 to the power, or 7 raised to the power of 16 plus 3. What would you do? So now, if you get something like this for each question on the paper, it'll take up a lot of space, right? Look, instead of this, if the teacher had to write all this 16 different times, it'll take a lot of space on the paper, right? So that is why exponents are used as a short form for repeated multiplication. So when you see this, you know that you are multiplying the base number here by itself 16 different times. So it's basically a short form. So I just use the example of a test on a test to show that it just saves space compared to writing 7 this 16 different times. If you just write 7 and 16 in superscript form, you're able to do it. You're able to express the same thing in a more easier way. That is basically the purpose of exponents. And also, this is from my introduction video, I'm just adding on to it. And if you haven't seen it, I'll leave it in the description below if you want a better understanding of it. But also, I would like to say one thing about the thing. I use the example of this. I use this example, and I said there's a ticker that came in the bottom. Let k represent any number, any real number, so basically any number, and n represent a positive integer. So many people got confused. So why isn't n any number? So that means exponents are not all about repeated multiplication. No, because now we have something different scenarios. So when it's a positive integer, so like for example 3 to the power of 3, then this method would work. It's repeated multiplication. But what about if we have negative exponents or fractional exponents, which is something we'll look in the next video? It wouldn't exactly be this repeated multiplication. So that is why I used this example and I labeled n as a positive integer only. And we're going to take a look at negative integers as well in this video. But I just wanted to make that clear. I use this example in my introduction to exponents video. So that's why I just want to make it clear. So in this situation only, n has to represent a positive integer. Because if it was a negative integer, this method wouldn't apply. It would actually be something else, which is on this side of the board. So without further ado, now let's get to this lecture. Okay. So negative exponents and zero exponent rule. So I'm going to first show you the formula, and then later I'll give you an example to show why this is the case or why we have to do it like this. So let a represent any number, assuming a raised to the power of 0. That is the zero exponent rule, or the zero power rule is always 1. Okay, that's simple. So I'll explain why it's 1 in an example soon. So I'll just give you an example. So this is straightforward. 3 to the power of 0. 3 is the base, 0 is the exponent. You can see how 0 is written in superscript, or it's written here in the top right hand corner of the base. 3 to the power of 0, 1. Negative 6 to the power of 0, 1. 1/4 to the power of 0, 1. So that's basically pretty straightforward. If it's raised to the power of 0, it's automatically 1. Now we get to the negative exponents part. So same thing here. let A, assume that A represents any real number, any number, and then X represents any positive integer this time. Because even though we have a negative sign there, if X represents a negative integer, then the negative here and the negative and a negative integer here would cancel out and it would become positive, and it would just be what we did earlier. It would just be A times A times A, what we'd had in the introduction video, however many times. So this case, in this example, negative X, in this example, negative exponents, A raised to negative X gives you 1 over the opposite positive power. So I'll show you how it works. I would say it's I'll give you a two-step process. You find the positive opposite power. So you'll get a negative exponent question. You find the positive opposite power. You find the positive opposite power, and then you just take the reciprocal of it. And if you remember from dividing fractions, reciprocal, and take the reciprocal of it. So I'll show you an example, but reciprocal, remember how we had in dividing fractions, 3 over 1. So the numerator, so we just flips. The numerator and denominator flip. So 3, and if you take the reciprocal of 3, it becomes 1/3. So that's what reciprocal is, if you haven't heard of it before. But I've already explained it in the dividing fractions video as well. So that is reciprocal. That is how we do negative exponents. So let me give you an example. Let's see. 3 to the power of negative 3. So how would we do this? So first we'll follow our two-step process here. So since it's easy, take the reciprocal of it. It's actually not, and then just make sure you solve. You solve it. You do all the operations. I'll show you how it works now. So 3 to the power of negative 3. What is our first step? Find the positive opposite power. So I'm just gonna, because the equal sign would make sense. 1. So 3 to the power of negative 3. What is the opposite power? Opposite positive power. So the base remains the same. The exponent will change. You could do negative 3. If you want to find the positive opposite power, you can multiply the exponent, just the exponent, by negative 1, and you would get 3. So that is the positive opposite power. 3, negative 3. So what is the next step? Take the reciprocal of it. So reciprocal, as we saw earlier, it would just be 1 over 3 cubed, or 3 to the power of 3. And then we would just solve it. So how would we solve it? Same as what we did for, now since we have a positive exponent, we can follow that formula we had in the introduction video. It's k is raised to a positive integer value. So k times k times k times k, however many times as indicated by our exponent. How many times should we multiply 3 by itself is indicated by the exponent. So 3 times 3 times 3, 1, 3 times 3 times 3. So 3 times 3, 9, 9 times 3 is 27. So notice here, even though it's a fraction, fractions are a way of representing a number, but fractions are also a way of representing number. But notice how when we're taking the positive, when we're raising our base to a positive integer, we had to multiply. But when we're doing it to a negative integer, we are dividing. We are doing the opposite. So positive, we are multiplying it, and when we're dividing, we are doing the opposite. Sorry, when we look at a negative exponent, we are doing the opposite. So that's what I just wanted to make that clear. And you think, oh, this is a fraction, how we're dividing? How are we dividing? Basically, fractions are a way of representing numbers. If we divide, this is a way to represent a number. If we divide this, 1 divided by 27, we would get some decimal value that is equal to this fraction. So we're just leaving it fraction, but here we're dividing. And when we're dividing, we're finding the reciprocal, and in our denominator, we're doing what we did here. Similar to how in dividing fractions, we we found the reciprocal and then we flipped the operation. So see how we found the reciprocal, and now we're not dividing. We're dividing still, but we changed the operation in the bottom. Now we are multiplying. We're doing what we were multiplying the base by itself, however many times is indicated by the now changed positive exponent in the denominator. So to make that clear, that is negative exponents, and this is the zero exponent or the zero power rule. And also I want to make one more thing. Any number that is raised to 1 is just the number itself, because you don't have any other number to multiply it with. It's just that number itself. So even if it's like 3 to the power 1, you just have equals 3. You don't have another number to multiply it with. So 3 to the power of 3, 3 to the power of 1 equals 3. So I just wanted to make that clear. So this is negative exponents. This is the negative zero exponent rule. But I just want to show you how we get here. So let me just erase this to make everything a bit more clear for you guys. Powers of 3 meaning where the base is 3. Okay, so I'm gonna illustrate an example here, because this somewhat helped me when I was first learning too. See, so 3 is being raised to various integers. They could be negative or positive, but they're just integers. So we're just looking at this example. We're looking at when a base is raised to an integer, whether it's positive or negative. It's an integer though. So just for this example, because so far we're dealing with exponents that are integers, positive and negative. We'll look at fractions in the next video. Okay, so as you know, we're multiplying the base by itself. How many times? We're not doing 3 times 2 as many people would do in the beginning. So 3 times 3 equals 9. 3 by itself, I was going to do 3 by itself is 3, because we have nothing to multiply it with, so 3. 3 by 0, if we follow our zero exponent rule or our zero power rule, anything raised to the power of 0 is 1. And then 3 by negative 1, we are going to take the positive opposite power. So 3 to the power of 1 is the positive opposite power. And then the reciprocal will be 1 over 3 to the power of 1, which is basically 1/3. So what is the difference? We've listed here. So what is the difference as I go down the exponents by one whole value? So from 3, when the exponent is 2, and then the exponent goes down by 1 to 1. So 2 goes down to 1, the exponent only. What difference do I see in the other part of my equation here? So what do I need to do to get 9 to 3? I'm dividing by 3. And then what do I need to do? And then if that relationship exists here, what am I doing here? So 3 to the power of 0, I'm going down 1. In terms of the exponent value, I'm going down 1 whole value. So what does that mean? So 3 to the power of 0, 3 to the power of 0 is 1. So what is the relation? How do we get from 3 to 1? 3 divided by 3 gives you 1. Notice what we're doing here. And then think about it. 1. And then how do you get from 1 to 1/3? We're dividing by 3 again, as we go down 1 whole value in terms of the exponent only, not the base. So see how as we go down each integer value in the exponent, we're dividing by the base. So that is why 3 to the power of 0 or any number to the power of 0 gives you 1, because you're dividing by whatever your base is. You're dividing that base by 3. So the base by itself to the power of 1 is the base, and then that number divided by your base, the base divided by base will give you 1. So that is why 3 to the power of 0 or any number to the power of 0 gives you 1. That is how we sort of come to our zero exponent rule. And then the number that is to left of the 0 is -1. Or the negatives. We enter the negatives now. So in the negative exponents, we're still continuing the same pattern still continues. So we're dividing our 1 by the base. So here division comes into play. As we go down, division comes into play. But see how as we go up from -1 to 0, -1/3 times 1/3, how do we get from 1/3 to 1? 1/3 times 3, cancel the denominators, you get 1. See, we multiply by 3 as we go up. And that just basically illustrates the idea of exponents. You just repeat it, you're multiplying the base by itself. Since the base here is 3. If it was 4, it would be multiplied by 4 and then divided by 4 here as we go down. So here times 3, 1 times 3, 3, then 3 times 3 gives you 9. As we go up, it's multiplication, which illustrates our power, our definition of the exponent, as I explained in the introduction video. And then as we go down in terms of the exponent number, so from 3 to the power of 2, we go down 1, so 3 to the power of 1. So as we go down, see how we divide by our base? And so we divide by our base, and see how that just works. And this is the idea of powers, and this is how we get the idea of negative exponents. And this is how we get this is like an illustration of why we get 1 as a result to our 3 to the power of 0 or anything to the power of 0, how we get our 0 exponent rule, and how we solve our negative exponents. So even if we go 3 to the power of -2, you will get 1/9. 3 to the power of 2, positive exponent, gives you 9. That would also be divided by 3. And if you want to go from here to here, going 1 up, when you're going positive, it would also be times 3. Since the base is 3, and we're looking at powers of 3. So that is how we find negative exponents. And that is how we find 0 exponent rule. This is the definition. I've given you the definition and an illustration of how it makes sense in the end. So thank you once again very much for taking the time to watch the video. I know it was a lot of stuff, and I hope I explained it to you the best way possible for you to understand. And in the next video, we'll be taking a look at fractional exponents, and we'll go from there. So thank you very much, and we'll meet each other in the next video.